Let's straighten these out. So we've got 41 through 48, 10.1. Okay, so what were you guys saying about 41?
It's a line. Ergo.
And
Keep
that's
rocking
just
her.
because it's a line, right?
Yeah, it's a line. Or I could think to myself, okay, what am I worried about? Well, I'm wondering about what things I can fit in here, right? Okay, so what numbers do you know how to multiply by 3?
All of them?
All of them. Can you subtract 15 from all the results?
Yes.
Sure.
Yeah, that makes sense. Okay, so all real numbers. Okay, how about 42?
All real numbers,
Why?
because it's a cube. You can get negatives.
Yeah, the cube root knows how to deal with negative numbers. So, yeah, I'm back at all real numbers. You see that?
Yeah.
That's really, multiplying by 3 is okay, subtracting 15 is okay, cube rooting is always okay. How about this guy, 43?
5
It's
to
on
infinity?
negative new problem.
Yeah, there's
Negative
problems,
infinity.
right? When are there problems on this one?
When you have 1, 2, or when you have 1, 2, 3, or 4, does all say?
When you get a negative
Zero.
on the square root.
Yeah,
And
when,
zero.
when there's a negative under the square root, right?
Right.
Okay, so I'm wondering, right? The thing I should be thinking to myself is, when is 3x minus 15 less than 0? Because that's going to cause me problems. You see that?
Yeah.
Okay, so when is 3x minus 15 less than 0?
All real numbers except negative infinity up to 5.
Okay, that's a very strange way to phrase that.
It's not negative.
So,
So it's not all real numbers. If it's not.
yeah, so I've got problems up till 5, right? Okay, so I'm thinking 5 to infinity is probably the right thing?
Mhm.
Or all real numbers except, yeah, negative infinity.
It works,
or
all
five.
right?
Is 5 included or not?
Yes.
Yes.
Yeah?
Because 0 is okay.
Because I get 0 and 0 is okay under square root. Awesome.
But if you go the other way, it has to be the curvy.
Yeah, if I was talking about the ones that you can't put in,
Yeah.
yeah, I need an open bracket. How about 44? The square root of 12 minus 4x? Okay, so there's like, I know 3 is the break, right?
Yeah.
You guys see that?
Yeah.
But I'm not sure whether it's things smaller than 3 or bigger than 3 that work. So I maybe could think about, I'm wondering when is 12 minus 4x less than 0, right? 12 minus 4x is something I know how to draw. What's 12 minus 4x look like?
It's a line, isn't it?
It looks like a line. It's got intercept,
Positive 12.
positive 12, and slope
Right.
Down 4 over 1.
down 4 over 1. So it looks something like this.
Yeah.
And I know this point is at 3,
Yeah.
right?
Yeah.
So when is this thing's output negative?
Negative. Infinity.
Below 3. After.
Below
Oh,
3
yeah.
gives you positive stuff.
After. I mean, like after.
So that's okay, right?
Yeah.
And everything bigger than 3 is problematic. You guys see that?
Mhm.
So I'm getting minus infinity to 3. What kind of brackets?
Open.
Open.
Close.
And close.
Open and close. Very cool.
Yay.
We could have graphed this one too, right?
Yeah.
See that?
Because that's a line as well.
Sort of alternate approaches. Okay, how about 45? I've got 1 over 3x minus 15.
Everything but 5.
Okay, how'd you get that?
Because if
You
you
know,
put
to the
5,
right.
then you get 0 on the bottom. I set the equation of problem 0 and solve it.
Very nice. Cool. Yeah, we want to set the bottom equal to 0 and solve, right? And then those are our problem spots. So we should pitch those. You guys all see that?
Mhm.
And then by this symbol, right, your book uses the kind of funny symbol here. I would prefer if you just used a minus sign, because what we really mean is grade school, like, take that away, right? All right, how about 46? Negative 1 over 4x minus 12.
Everything but 3.
Yeah.
All reals but 3. For the exact same reason, right?
You said it's a 0. So it's set the bottom 0.
Yeah, we'll set the bottom equal to 0. And then that's going to be our problems, right?
Yeah.
Okay, how about 47? Absolute value of 3x minus 15? Why?
Because that happens afterwards. You can plug in whatever number you want. The absolute value is after everything.
You guys see that?
Mm-hmm.
Absolute value also doesn't care, right? It
Yeah.
knows how to deal with all the numbers. So if I thought about, okay, if I put a number in here, I'm going to multiply by 3, totally fine. I can do that for everything. I'm going to subtract 15, totally fine. I can do that for everything. Then I'm going to take the absolute value. Yeah, I know how to take absolute values for everything, right? If it's positive, it stays what it is, and if it's negative, it turns into the positive. So, thinking Team Rocket R on that one.
So it works.
All right, now how about 48? X squared minus 5?
All real numbers again.
All
You
the
don't
things.
Why?
Because you don't run into any problems, you can square
You can
anything.
square whatever you want.
You can square whatever you want, and then you could certainly subtract 5 from it. Or I could draw a picture for this one. I could draw a picture for the other one too. But what's the picture for this one look like?
It's a parabola.
It's a parabola,
That's
shifted,
downwards 5.
down 5. You guys cool that?
Yep.
Alright, so not so bad. What are the problems we're looking for with functions? Well, we have problems when we're dividing, right? Possibly by 0. And we have problems when we're taking square roots of things that
Might have negative.
might have negatives, right? Otherwise, we don't know any problems other than those so far. As we add more functions to our vocabulary, we'll have more things to watch out for. But for right now, you really only have 2 prohibited operations there, divide by 0 and square the negative number. Questions on any of these? Yeah.
When they were inventing this, did they find the problems like when they were playing with it, or did they like look for the problems, or the problems just appeared? I wonder the history behind this.
So, good question. For division by 0, it's really a question of, do I know what it means to allocate things to 0 groups? Like, do I know how much each group should end up with? Well, not really.
I just remember like the first guy was thinking, like, divided by 0, what does it mean? And then he would like
Yeah,
do a thing on it.
this was sort of developed at a weird time. This was before we had the modern notation that we used. And so, yeah, this notation is Arabic notation. A lot of math was developed prior to that, and to be totally honest, I'm not sure what the first result was.
Okay.
My guess is that it was just allowed at the beginning, and then people came to realize that there were problems with dividing by 0.
Makes sense.
As to square rooting negative numbers, a good theory for what that looks like wasn't developed until much, much later. That was sort of a weird thing until Leonard Euler, I think.